Hello, friends. We thank God for another new day. Today, we want to continue with our lessons on partial fractions. And so today will be partial fractions 2. The last time we met, we treated partial fractions 1 and we looked at linear factors as the denominators. And so today, we want to move on to quadratic factors. And for quadratic factors, this is what we are going to do. If you look at this one, this rational function at the denominator, we have a linear factor and a quadratic factor. So we want to see how we can capture that in the general form. So for this, the a will come, and then we have our denominator x minus 1. That's a linear factor. But for the x squared plus 9 as a quadratic factor, we introduce bx plus c at the numerator level. So this is how we capture this type. And so take note of this. All right, so let's apply that in the question. Express this rational function in partial fractions. And so we start. So the whole of this will be equal to a on x, this is a linear factor, and then bx plus c on x squared plus 2. Right, so we multiplied every term, both on the left-hand side and the right-hand side, by x into x squared plus 2. When we do that, this will be cleared, so we get this. This one, the x will be cleared, so we get ax squared plus 2, and then this one will be cleared, and so we get bx plus c times x. So from here, we are going to compute our a, b, and c. So what I'm going to say that we shall substitute 0 for x in our expression here, and that will give us 3 equals 2a. So we make a the subject by dividing both sides by 2. So a will be 3 on 2. So we've been able to compute a. Now we have our expressions to equal to this one. We expand, then we group the like terms. So if you want to compare coefficients, then coefficients of x squared will be a plus b being equal to 1. So a plus b is equal to 1. But we have the value of a to be 3 on 2. So we subtract 3 on 2 from both sides. And so our b will be negative half. Now for c, when we get back, you see that coefficient of x is c, but here coefficient of x is 0. So c is equal to 0. And also, we computed our a by substituting 0 for x, but we can also look at the constant. 2a on the right-hand side will be equal to 3, which is also a constant. So our a will be 3 on 2, right? So we can use any of them to compute our a. With that established, we now come to the question, and then we finish everything. And so we say that we have this as our value. So let's take our time and then write it very well. So say that therefore we have everything in place. So I'm going to take my time and write it well for us to see. Okay, so we have it this way. So we say that okay, so that does it for this one. So our expression will be equal to that. So look at it again and see the explanation that was carried out and follow the trend. Now let's go to another question. I want to express this rational function in partial fractions. We are going to express this in partial fractions. And so what we are going to do is that write the whole of this equals a on x plus 1. Remember that x squared minus 1 is difference of two squares. So b over x minus 1. So I want to multiply these two, it gives us x squared minus 1, and then the quadratic factor. So we introduce cs plus d as the denominator over s squared plus 1. Now we carry out our multiplication. So we multiply every term on the left-hand side and right-hand side by the denominator. So when we do that, this will be cleared on the left-hand side. So we get this on that. So this we divide this by x minus 1. So we get a into x minus 1, then s squared plus 1. Then b on x minus 1, this will divide us, so we get x plus 1. So x plus 1, then s squared plus 1. And this will divide that, so we shall get s squared minus 1 times cxd plus d. And so that does it for this aspect. Now, we want to substitute 1 for x. So when we do that, so put 1 here, put 1 there. When we put 1 here, this will be cleared. We put 1 here, this will be 2. Put 1 there, this will be 2. 2 times 2 is 4. So 4b equals 3. 1 plus 1 plus 1, 3. And then we put 1 there, this goes away. So our b will be 3 on 4. Now, I want to substitute negative 1 for x. So when we do that, that also gives us, substitute negative 1 here. When we do that, we shall get 1 equals negative 4a. Then we divide both sides by negative 4. So we shall get a equals negative 1 on 4. The next is that we are going to substitute 0 for x. When we do that, we shall get, so 0 here, 0 there, 0, 0, 0, 0, 0, 0. So this one will give us our negative a. And then when we put in the a, which is also negative, so we get positive 1/4. And then our b is 3/4, then minus our d. So this whole thing will give us 1. And then when we actually rearrange, we shall get d equals 0. Now we can now compare coefficients and see b minus a is equal to 1. So we already have our b and a, so we don't need to waste time. Now coefficient of x, when we compare, we shall get a plus b minus c equals 1. And so a is minus 1 over 4, b is 3 on 4 minus c, and that is equal to 1. So we rearrange, this will give us 2 on 4, which is half. Then we rearrange, we shall get c giving us negative half. So that is how the whole thing will be. And then we now slot in the values as we started, and this will be the answer. So we put in our a, b, and then our c, remembering that our d is 0. So go through the second question. Gradually. 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 Right. So that brings us to the end of partial fractions 2. And we looked at quadratic factors. And we've seen how we can capture them in the general form using letters A, B, C, D, and so on. And then from there, how we can compute the constants and then slot them back to obtain the expression that we yearn for. Thank you for your time. I hope to see you another time for more lessons. Thank you so much.